So simultaneous equations, there's two main ways of solving these, using this elimination or the substitution. I'm going to go through elimination here. First off, I hate fractions and things like this, so actually what I'm going to do first, and to keep it clear to the examiner and everybody else, I'm going to continue to write down what I'm doing. So equation 1, doubled. Highly recommend you write down, you label your equations and do this. It makes everything so much easier for people who are marking to mark, and if you do that, then they're marking thousands of papers, you're more likely to get their goodwill. So x plus 2y plus equals 16. I've doubled every part of that. Now I can see if I just write equation 2, just exactly equation 2, not going to change it at all. The reason I'm not going to change it is because it's got a coefficient of 2 in front of the y. Well, it's actually got a coefficient of negative 2, but that's still alright. Because I can eliminate here, as me saying, it's an elimination method, by adding these two together. Equation 1, which has been doubled, plus equation 2. If I add those two together, now a lot of people always ask me when I'm teaching this, how do you know whether to add or subtract? Essentially you're trying to eliminate. If we subtracted these here, we would also get rid of the x's. We could subtract these two equations. I'm adding them though, so just look at what happens when you do them. So x subtract x gives, sorry, I'm adding, aren't I? Gives me 2x. Then 2y subtract negative 2y. If you subtract negative 2y, I'm just going to write this up here so that we can all see what's going on. That's the same as adding 2y. Oh, hold on, sorry, I'm adding, I just can't get my head around that. Adding negative 2y, which is the same as taking away, so that means I'm going to end up with 0y, so nothing else on the left hand side of the equation. Now, adding these two as well, I get 18, so that means x has to be 9 halfway through the question. Thankfully, it's very hard to forget that you need to do y here, because they've told us we need to get y here. So to finish with, I'm going to substitute that back into the equation. I can use either one of them. I'm going to look at equation 2 again, still labelling everything I do. So instead of writing x, I'm going to write 9. So 9 take 2y is 2. So negative 2y is negative 7. Divide both sides by negative 2. Gets me 3.5 or 7 over 2. Either one of them would be perfectly acceptable. 3.5. Right now I'm going to try and squeeze in the right hand side here. Substitution method. And to do that, so this little box over here, I'm going to draw we're dealing substitution, just in case you're interested, and I'm going to do well to fit it in there. I'm going to look at equation 2 and just rearrange that slightly to get x equals 2y plus 2 by adding 2 to both sides. Now I know that's what x is. I can substitute that into equation 1, and I could have done this with either one of them. So I have a half, and instead of writing x, I'm going to write 2y plus 2, and then the rest of equation 1 is plus y equals 8. So all I've done is swap my x in that equation for that 2y plus 2. Now I expand those brackets, which means just halve it, so I've got y plus 1 plus y equals 8, so that's 2y plus 1 is 8, oops, 2y plus 1, so 2y is 7, and that gets me y is 3.5, which I can then substitute into the other one. So that's the substitution method. You rearrange one equation to make one of our unknowns the subject to the formula, and then substitute it into the other equation. It's the one to use when you're solving quadratics like this, but either of these methods are absolutely fine. We'll get you all the marks on a simple linear one like this.